In this video, I am going to explain apparent weight of a man in a lift or elevator. This is a very important information, and the question based on that core concept you will get in the board exam, not in the board, it is in the directly in the competition part, because it is the part of mechanics physics. So suppose a person is sitting or standing on a weighing machine. Suppose a person is standing on a weighing machine and m is the mass of the person. So we know that net weight of the person is mg. This is the actual weight of the person, and as the person is on the weighing machine, so weighing machine will apply a force of reaction, and reading in terms of a force of reaction, that is R, that is the actual weight of the person. So we can say that suppose the person on the weighing machine, then we can say that this R must be equal to mg. Now if the entire part is taken in a lift, and that lift, suppose it is connected by a lift, then what will happen its weight, whether it will remain same or it will increase or it will decrease, that we have to see in this part, that is apparent weight. So suppose the lift is in the rest condition. I have already explained free body diagram in my first video, that when we are going to start numericals, first we have to show or we have to know the net force on the body. That is very important, and in which direction the body is moving. So if suppose the first condition I am explaining, that first condition, lift is in rest, that is lift is not in motion, so acceleration of lift is 0. So the net force on the lift will be 0. So what are the force acting here? R and mg, these are two forces. We can say that R minus mg or mg minus R, because here net force is 0, is equal to net force is equal to 0. So here R is equal to mg. We can say that if lift is in rest, the person is in the lift and lift has not started to move, on that time the apparent weight and actual weight of the person will remain same, it will not change. Second condition, if lift is moving uniformly, very important point, lift is moving uniformly, and I have already explained my second video, uniform motion, equal distance and equal interval of time, and such type of motion acceleration is 0. So here acceleration of the person is 0. So in this case, again, suppose the body is moving uniformly upward. So here upward is going, that is this force is, we will take this force minus this force. So R minus mg is equal to net force. This is the concept. R is the weight that is offered by the weighing machine. So here net force is 0. So we can say that R will be net force, because acceleration is 0. So force will be m into 0, that is 0. So here also the actual weight and apparent weight, that will remain same, that is apparent weight of the person is the actual weight of the person. Third case, if lift is accelerating downward. A very, very important information. If lift is accelerating downward, here lift is moving down. Here lift is moving down. So we can say that lift is going down here. And I have already explained in FBD, free body diagram, this force must be bigger than this force. If the body is going down, so this force must be bigger than this force. If the body is going up, this force must be bigger than this force. So here we will draw the diagram. mg minus r is equal to net force, and mg minus r, this r dash is the apparent weight and this is the actual weight. So here net force is equal to mass of the body into acceleration. So r dash will be mg minus me. So we can say that here apparent weight of the person, of the body, will be less than the actual weight. This is the actual weight, mg. And from mg, ma is going to be removed. So apparent weight of the person will be less. That means person will feel lighter. So we can say that here apparent weight will be less than actual weight. A very, very important information, that if lift is going down, then apparent weight will be less. Now another condition, suppose lift is moving upward. Lift is accelerating upward. Here, lift is accelerating upward. In this case, what will happen? Suppose lift is accelerating upward. In this case, what will happen? Just we have to see FBD, free body diagram. That is very, very beneficial when we are going to solve numericals. Here the lift is going upward, accelerating upward. So this force must be bigger. So we can write apparent weight like R double dash. We use different symbol because this is the actual weight. R is equal to mg. That is the normally shown by the weighing machine. But actually what it appears, that we have to find. So we can write R double dash minus mg is equal to net force. So R double dash minus mg is equal to m into a. So R double dash is equal to ma plus mg. A very, very important information. In this case, the apparent weight of the body is more than actual weight. See, ma is added to mg. So the person will feel heavier. Here the weight of the person will appear more. So here we can write that apparent weight greater than actual weight. Very, very important information, that what will happen if lift will moving uniformly. Acceleration is 0, actual weight is equal to, the apparent weight and actual weight both are same. If the lift is in rest, here also actual apparent same. If the lift is accelerating downward, the person will feel weight is less, apparent weight is less than actual weight. And if the lift is accelerating upward, here apparent weight is more than actual weight. Then last condition, that suppose this thread breaks. Very, very important information, that is fourth point. If lift break, the thread of the lift breaks, that means here the entire lift comes under gravity. Here the motion of the lift will be under the gravity. So we can say that here motion of lift is under the control of gravity. So in this case, here the mg minus r is equal to, in place of net force we will write m into g, because acceleration becomes equal to g. So r will be 0. That is, apparent weight will be 0. This is a very, very important information, that is called weightlessness. Weightlessness. So I have given 5 information related with apparent weight of a man in a lift or elevator. First information, when the elevator is rest. Second information, when the elevator is moving uniformly. Third information, when the elevator is accelerating downward. Fourth information, when the elevator is accelerating upward. Fifth information, that is free fall. It is also called free fall. It is also called free fall. The lift, it fully comes under the control of gravity. Here the apparent weight of the body will be, person will be 0. So these information is going to be very, very important for the solving the numericals question. One question I want to discuss here, that is, a man standing in a lift hold a spring balance with a load of 5 kg suspended from it. What would be the reading of balance when the lift is descending with an acceleration of 3.8 meter per second square? Very, very important. A very, very important question. One question I want to discuss. Here it is given that a man standing in a lift hold a spring balance. So with a load of 5 kg, so here mass we will take 5 kg. I want to write the question also, that is important. A man standing in a lift hold a spring balance with a load 5 kg, with a load of 5 kg suspended from it. What would be the reading of balance? What would be the reading of balance if lift is descending with an acceleration of 3.8 meter per second square. So if you remember the formula, that when lift is going down, just you remember that this is the, suppose lift, here person is there, here A is 3.8, descending is given, that is going down, ascending up, descending down, so 3.8. So we can write here formula, that is mg minus r is equal to ma. So R is equal to mg minus ma. This concept will apply here. So actually what is the mass given? Mass is given 5. So we can write R is equal to mg minus ma. M is common. G is here, G value is given 9.8 and A is 3.8 and mass is given 5. It is 5. So it is 30 Newton. The reading of spring balance will be 30 Newton. This is the very important information, the reading. So question is, what will be the reading of balance? This is 30 Newton. So in this way we can solve the question based on apparent weight of a man in a lift or elevator. Next video I will explain some other matter related with mechanics. Thank you.